Hi guys, welcome to our channel of Sciences and Mathematics. Today we are going to look at sample questions in vectors. This one, of course, follows a video that we have done on vectors, and that was on the concept of a dot product of vectors and the distance between 2 points. So those two sample questions are going to, three sample questions are going to complement on that video, and we're going to see on how we can be able to apply the concept that we have learned on that specific video. But of course, we shall have a recap to remind us. And I'm going to put a link of the video in the description box so that you can be able to just have a concept of the two areas that we're of course going to discuss. So in this case, I welcome you to the topic. Let's go ahead and try to see how we can be able to solve those sample questions. So first I'm going to just have a quick reminder of what we have discussed, so that we can connect from there and continue. So we have discussed last time about the concept of vectors in two-dimensional space, and we said that suppose we have two vectors u and v in two-dimensional space, and theta as the angle between the two vectors, then therefore we can illustrate figuratively using that particular figure in order to show how that concept of the two vectors and the angle between them can be illustrated. And then we said that we can find the dot product of the two vectors u and v by finding the product of the norm of u and the norm of v and the angle between the two vectors. So therefore, that is what we said. And then we said that if these two vectors are in two-dimensional space, then we can use the rectangular coordinate system in order to describe the vectors using the x and y axis, maybe that coordinate system. And we gave an illustration of this particular case and say that if P is the position of a particle in two-dimensional space, then we can be able to illustrate the velocity components of that particular particle using the component for velocities in the x and y direction. And therefore we say that this can be represented using finding the square of the sum of those two components of the velocities as such. And therefore we extended this one into a three-dimensional space and say that if a particle is moving in a three-dimensional space, then we can be able to use this coordinate system of the x, y, and z direction, bearing in mind that that's the origin and this is the position of that particle P. And we said that we can be able to illustrate the velocity components of this particular particle in three-dimensional space by this Q, O, R, and P. So therefore we can say that this velocity in the x component is V1, the y component is V2, the z component is V3. And we say that we can be able to represent this velocity component for this particle, that is the norm of v, using those three-dimensional space velocities by writing as v is the root of v1 squared plus v2 squared plus v3 squared. So by finding the root of those three components, then we can be able to describe the norm of vectors in three-dimensional space. Now back to our discussion for today. We're going to have a few sample questions which are going to assist us in trying to figure out how we can be able to exploit these three concepts that we've learned for finding the distance between 2 points in space. Now suppose we are asked to, this is sample question 1, to find the dot product. Find the dot product of vectors u and v given u is equals to 0, 0, 1, and v is given as 0, 2, 2. So in this case, having been given the components of those two velocities, Then we shall therefore try to illustrate on how we can be able to find this one. And now assuming this is the position of that specific particle, so therefore we can just give a rough estimate for this and the x, y, and z components. And we've said that okay, this is 1, 2, 1, 2, and then we've got this is 1, 2. Since this is the range of those particular particles, we can just describe. So therefore, for the point u, we can be able to look at its components. For the x and y components, this is x, y, z, x, y, z. Now for u, the x, y is 0, and then for u, it is just 1. So therefore, at that point, we will just describe it using this particular point. So therefore, for point v, it is 0 in the x direction, 2 in the y direction, and 2 in the z direction. So therefore, we are going to have it at this particular point. So that's where that particular particle is going to be located in space. So therefore, for us to try and find out how we can be able to find the dot product of those specific particles, as I've said, there was a general formula for us to try and find out how we can find the norm of V in this case. So it's going to be the change in x direction, which is x2, x1 squared plus y2, y1 squared plus z2, z1 squared. So in this case, it's just finding the difference or the change in these specific components of those particular vectors, whereby we'll see that this is going to give us, for the norm of v, this is going to give us change in x, 0 minus 0 is going to be, therefore the root of 0 minus 0 is 0 squared plus this y, this is 2 minus 0, it's going to be 2 squared plus z. For z component, it is going to be, of course, 2 minus, just a minute, so that's going to be 1, 2 minus 1, 1 squared. So therefore this is going to be the root of 4 plus 1, which is going to be the root of 5. So in this case, we're going to see that I'll just do away with this. We said that this dot product can be represented using this particular formula, the norm of V, the norm of U, the cosine of theta, which is what's the angle between them. Now, of course, we were given, so that one I forgot to indicate, we were given theta as 45 degrees. So therefore, we're going to use that particular figure. So in this case, we have found out that the root of, this is the root of 5 as the norm for V. Now we're going to find the norm for U, which is going to be, so just a point of correction, I realize that we must have gotten lost somewhere. So given that we are going to find the dot product for the two vectors, that is vector U and V, and given those three components, and we have said that the dot product for vector V and U is given as the norm of V or the norm of U, and the product, that is the product of the norm of V and U, cosine of of the angle theta. Now, in this case, we are told to find the dot product of the two given vectors, given that theta is equals 45 degrees. So in this case, we're going to look at these two concepts, whereby first, step one, we find the norm of V, which is going to be given. This is in a three-dimensional space, so therefore we're going to use these components, which is the square of 0 plus square of 0 plus this is the square of 1. So therefore, for us, the norm for V is going to be the square root of 1, which is going to be 1. So therefore, this is the norm for U. The norm for V is going to be given as the norm of those components, where 0 squared plus 2 squared plus 2 squared, of course, which is going to give us the root of 8. This one we can simplify it further and say it's the root of 2 times 4, which is 2 the root of 2. Now that is correct. So therefore, having found the components for the norm of U and V, we can just do away with this and do a substitution for that case because of space. So therefore, I can just indicate that the norm of U is 1 and the norm of V is 2 the root of 2. Okay. Now the cosine over 45 degrees from trigonometry, of course, we talked about the concept of the unity circle. The cosine for 45 is going to be 1 over the root of 2. So therefore, we're going to represent this dot product using the product of these components that I've listed below this formula, which is going to be 1 times 2 the root of 2 times 1 over the root of 2. Now we can be able to cancel those and then find out that that dot product is going to be 2, which of course is a scalar quantity. So therefore, that is what we're going to use in trying to find the dot product using this particular formula. So first find the norms of the two components of those velocities, and then we can be able to derive this one from the unity circle that we talked about using the cosine concept that we talked about in trigonometry. So in this case, generally we talked about this particular formula for dot product, and we had given a condition that so long as the vector V or U are not equal to 0, then this particular formula for the dot product is applicable. So generally we can say from this formula that the cosine of theta, therefore, given other aspects of this formula, the cosine of theta can be given as the dot product for vector V and U all over the norm of V and the norm of U. So this first sample question is trying to assist us on how we can be able to navigate and find maybe the dot product or maybe a respective angle between the two vectors given this particular information. So in that case, that is the first sample question. Now the second one we're going to look at is going to give us a general formula on how we can be able to find a dot product still given the components, or how we can be able to determine the angle between the two vectors or the three vectors, the vectors in three-dimensional space using what we have discussed. So I'm going to do away with this. Try to give that sample question 2 here. So it says, let U be a vector, or U be a point, in that U is given as 2, -1, 1, and V be another point which is given as 1, 1, 2. So we are told to find u v and the angle between them. So still we're going to use the concept of vectors that we had been taught, and to try and find out how we can be able to calculate that. Now in this particular case, I'm going to extrapolate on using this specific illustration. But of course, I'm going to mention another formula here that we're going to deal with in another topic, and that is the cosine rule. So in this case, I'm going to represent these two particular points in two-dimensional space using these two specific points. That is for u, -1, 1, and then for v, 1, 1. So of course, it will not be proportional to the scale I've just put on there. This is just for illustration purposes. So therefore, this one we can be able to represent it from this particular point as the norm of v, and this is the norm of u. So therefore, we are going to see that this is the velocity component for v, and this is the velocity component for u. Now in that particular case, we are going to see that by the cosine rule, we can be able to illustrate v, u dot v, as the sum of the product of these two specific components, that is for v1 u1 plus v2 u2 plus v3 u3 plus vn un. So in this case, this is going to give us a different scenario, but of course when we discuss about the cosine rule, we're going to expand on that one and try to see how we come across that specific concept. So I feel that since we are already going to mention that one beforehand, it's good for us to just try and mention it out so that it does not contradict what we have already discussed insofar as the dot products are concerned. So therefore, in this case, we're going to just go ahead and try to solve our sample question. So let u be this point and v be that point which I've illustrated on the board, and then find v dot u dot v. Now I've said that we are going to exploit this concept of the cosine by the cosine rule, and try and figure out how we can be able to find that. So therefore, using this rule, it's going to be u dot v equals u1 v1. We just do a multiplication of the respective components, and then we find it is 2 times 1 plus, so it's a sum of that, so it is plus -1 times 1 plus 1 times 2. So this is going to give us this is 2 minus 1 plus 2. It's a scalar quantity which is going to give us 3. So by the cosine rule, we're going to find that that is going to give us the product. But our point of concern, I hope that we have seen this illustration. Now for our point of concern was that using the concept of the cosine of theta equals u dot v, and then the norm of u, norm of v. Therefore, in this case, of course, we have tried to find the denominator, the numerator aspect of that specific question. So therefore, it's going to be 3 this, given that this is the cosine of theta, divided by, now the norm of u, we're just going to use the normal formula that we have discussed, and just write it here. The norm of u equals the root of 2 squared plus -1 squared plus 1 squared, which is going to give us the root of 6. So basically for u, it's going to be the root of 6. times the root of v. Also in that order we're going to use, the norm of v, 1 squared plus 1 squared plus 2 squared for this. So this is also going to give us the root of 6. So it's the root of 6 by the root of 6, which is going to give us 3 over 6, which basically is the simplified form is a half. So therefore we have found that the cosine of theta is equals a half, and we were supposed to find, so this particular component is this one. So we were supposed to find the angle between them. So we're going to find the cosine inverse of a half, which is going to give us 60 degrees. So in this case, of course, we're going to use different approaches in trying to find out how we can be able to work on such a kind of a problem. And this is going to give us a clue on how we proceed with others. So I'm going to have a sample question in our next discussion, maybe having all these components of the dot product and the norm, and then we are going to look at the, or maybe when we are trying to deal with the cosine rule, I'm going to mention these components so that you can be able to do a relationship and see how they complement one another in trying to find solutions for such a kind of a problem. So that is it for today. I hope that we have already maybe tried to have a relationship between this first and second video that we've done on vectors. And this is going to assist us, of course, in trying to find out some of the problems that we talked about in visualizing the aspect of position, displacement, acceleration, velocity, etc. Whenever we come across problems in physics, mechanics, or maybe which are applications in some of the fields like engineering. So for that case, that is it for today. Bye guys. God bless.